Us. Okay, so hello everyone. We are thrilled to introduce our project, GuideSense. It's a real-time navigation for visually impaired people. My name is Afzia Wagnes, and I'm here with my team members. We are making a web app which is used for navigation, safer and more accessible for blind and visually impaired individuals. Uh,
Uh,
I am a, I am the project manager and the developer.
Hi, my name is Kayin Chen. I'm the database administrator.
Hi, my name is Dinesh Sukwera and I'm the developer. And here is my friend Ritesh Singh, and he's a developer.
Hello, my name is Osham Makwana. I'm a backend developer for this project.
And hi, I'm Vaibhav Thaplial, and I'm the developer lead and the front-end developer for this project.
Hi, my name is Min Jung, and I'm the quality analyst for this project.
Hi, my name is Rishikesh and I would be helping with the content development.
Okay, so I'm presenting the problem statement. Navigating through the everyday environments presents significant challenges for blind and visually impaired individuals, whether it's crossing busy streets, avoiding moving vehicles, or lacking real-time guidance. These individuals face numerous obstacles that can hinder through mobility and independence. Traditional mobility aids like canes and guide dogs, while helpful, often fall short in providing comprehensive and real-time information about obstacles, directions, and surroundings. This means that blind and visually impaired individuals are frequently navigating through without the full picture, leading to an increased risk of accident and restricting their independence. This lack of real-time situational awareness can be particularly dangerous and can limit the ability of visually impaired individuals to move freely and confidently in their environments. Therefore, there is a pressing need for an innovative solution that leverages modern technology to enhance mobility and safer for the visually impaired community. Our project aims to address this need by creating a web app that uses advanced object detection and voice commands to help blind people navigate safely, and the app will warn users about obstacles, provide directions, and describe their surroundings in real time, offering a comprehensive and defendable navigation solution. By combining these technologies, we hope to empower visually impaired individuals to navigate their surroundings with greater ease and confidence.
For project description, so as the Abzia stated the problem, we will try to solve the problem by creating a project for the blind individuals with the following technologies. We have used real-time object detection, the YOLO model as the AI model, and we will alert the users through voice navigation and GPS integrated in a project for route detections. Also combining GPS and AI object, we are aiming to make it safer for blind people to navigate through the streets.
The team working engagement we have divided into three parts. The first part is like communication. The team will communicate through email and WhatsApp, ensuring smooth coordination. A mandatory team meeting will be held every Tuesday at 9 p.m., where all 8 members should join. Additionally, the technical team will have a separate meeting on Tuesday and Thursday to discuss their task and update. If a member cannot attend the meeting, they should inform the team in advance and stay updated on the discussion. The second part is on work division and participation. Work will be divided equally among the members based on their skills, with Jira and GitHub used for tracking the progress. Each team member must provide updates twice a week, complete the task before the deadline. If someone is unable to meet a deadline, they should inform the team so the workload can be adjusted accordingly. Absent members are expected to support the decision made during the meetings. Third parties respect and collaboration. Respect and collaboration are essential to the team's success. Everyone should feel comfortable sharing their opinion without judgment, as team work relies on collective knowledge and diverse perspectives. Members are expected to respect each other's schedules and contributions while working towards a common goal. Yeah, next.
This is the improved project schedule as follows. The dates are the same for Sprint 0, Sprint 1, Sprint 2, and Sprint 3. With the completion of Sprint 1, we have added and included MVP, which includes an authentication with YOLO V8 and a Google Maps implementation, which we will demonstrate later at the end of this video, and designed diagrams, including the context, class, ER, and etc. other diagrams as well. For the other two sprints, we will also include for sprint 2, connecting users, connecting all components, and a text-to-speech functionality. And for sprint 3, we will include a final tested MVP product, which includes both the front end and back end capabilities.
So, well, here comes to the persona slide. So, as we know that we talk about the last sprint. So the persona slides as like for the it's like an independent blind user. The first thing is like she's name is Aisha Khan and her age is like 32. And well, she is an occupational is that who has a software developer. Well, the this her background is like she's highly tech savvy and relies on assistive technology. And she's motivated to use the tools that enhance her development and streamline daily activities. So, well, these app scenarios that she want to use the app for the navigation while she was working and with the unfamiliar areas and identify the objects which could be barrier for the seamless tasks too. So mostly her goals will be increase independence and improve the access to information, like enhances safety while navigating the streamline and daily task management. So coming to the next slide, here come the personas who concern the family member like is Robert Chen and her age is like 65. So he's her relationship with his like son is visually impaired with and he was worried about his mother for safety and I hope this help can get stay connected when she's ensuring she's doing okay. Like for this perspective, her this app use as a scenario like robots want to use that app to track his mother locations or any receive the alerts where if she deviates from other routes to something randomly. So this can remote assist her with tasks like medication reminders and communication with her easily through the app scenarios also. So her goals is to increase the peace of mind, like improve the communication with his mother and ability to provide his remote support too. So coming to the Personas 3, like see you can see him like he's so young, like partially teenage manager. So his name is David Miller and his age is like 16. Wow. Okay. Her background age is like David is like a low vision due to high genetic conditions. Like he can see some things, but that height of the glass of magnifiers. Uh, this app scenario wants to use for the app like to identify the colors, like navigate public transportation and like access audio descriptions of videos and other media, etc., etc. So this app that is easily customizable to his specific visual needs. I hope so. So his goals needs to be increased like independence and improved access to information, enhanced social participation and greater confidence in the navigation to the world.
Yeah, so the programming languages we are going to use is Python for the backend, and we are also using Node.js as our runtime, backend runtime. And for front end, we are using React. And for authentication and authorization, we are using Clock service. And as a database, we are using MongoDB, and we are going to host our models and servers on AWS. And the tools to assist us, we are using OneDrive for sharing all our files and work. And Jira, we are using to track our stories and for project management, like to see the velocity and burn down charts. And for code versioning, we are using GitHub. And for sprint retrospective, we are using the Idea Boards website. Next slide, please. Dinesh, can you move to next slide?
Yeah, my bad.
Yeah, so the AI model we are using is called YOLO, which stands for You Only Look Once. So it is a cutting edge object detection model, which is known for its exceptional speed and accuracy, making it ideal for the real-time application. Unlike the traditional object detection methods that analyzes an image multiple times, YOLO processes the entire image in a single forward pass of the neural network. And this design allows it to detect objects significantly faster than the other models while maintaining the high accuracy. The model works by dividing an image into a grid where each cell is responsible for detecting objects within its region. It predicts bounding boxes, class labels, and confidence score for each detected object, ensuring precise localization and classification. YOLO model. It is pre-trained on the COCO dataset, which consists of 80 object categories and over 200,000 images, and which makes it a highly effective in recognizing a wide variety of objects. To enhance detection accuracy, YOLO applies NMS, non-maximum suppression, which eliminates redundant and overlapping detections, ensuring that only the most relevant and confident predictions are retained. Its real-time capabilities combined with high precision makes YOLO widely used in applications such as autonomous driving, surveillance, medical imaging, assistive technologies for visually impaired individuals. Next slide, please. Yeah, so for MVP, we worked on these three areas. First one was object detection to make YOLO model work on real-time video. The other thing was the Google Maps API. And the final thing which we worked on was the user authentication and authorization part. Next slide, please. So yeah, in our system, what we are doing is a web browser, which is a client, connects to the server and initiates a WebRTC offer to establish a peer-to-peer connection. The server processes this offer, sets up a connection, and responds with an answer to complete the handshake. And once the handshake is complete, the video stream starts, and each frame is received by the server. It is processed through YOLO for real-time object detection, and then it is enhanced with visual indicators like such as bounding boxes around the detected objects. And once that is done, it is sent back to the client for displaying in real time. So this setup enables low latency object detection and visualization, making it suitable for applications, like assistive technology, surveillance, and autonomous systems. Yeah, so the frameworks which we used in this sprint was like Fast API. So Fast API is a modern, like high functioning performance web framework for building like APIs with Python. Then we use WebRTC, which is like open source tech. It is used for like browser to browser, peer-to-peer connection. We can use it to send data, to live feed the videos, and etc. And the third thing, we use Google Maps API for our maps functionality.
This architecture diagram shows that the actor, when the camera is on, can capture speech results, log in and register, see real-time object detection, update preferences for detection criteria, accessible users, including guardians, and change the accessibility on the UI, including font, color and schema, and share location. And this is done through the front end, which consists of React and JavaScript. And from there, capturing results from text-to-speech functionalities, to the backend is one capability. The backend, which includes Node.js and Fast API, from there can be used to log in, register, and authenticate a user account through the Clerk UI, request a location through the Google Maps API, and save common routes that are used by the user to the database, which is established in MongoDB. Next slide, please.
Okay, this context diagram provides a clear overview of how the app interacts with its users and external systems. So the central system is the GuideSense web app. It serves as the hub, integrating advanced technologies to deliver its features. It processes inputs, run object detection algorithms, and provides real-time feedback to the users. Then comes the YOLO module. The app uses the YOLO module for object detection, which processes camera data in real time to identify the objects in user's environment. Once an object is detected, its description is sent to the next component for communication. Then comes the voice assistant module. It acts as the feedback system. This module is critical for accessibility, converting detected objects into verbal description using text-to-speech technology. Users receive real-time audio feedback, enabling them to navigate their surroundings safely and independently. Then comes the visually impaired individual, the users. They interact with the app through simple activation methods such as voice command or tactile input. The app's primary goal is to empower them with real-time guidance and increase the independence. Then comes the family members, act as the support network, which get the access to location of the data fetching by GPS. And the visually impaired users interact with the app to detect obstacles and receive voice feedback. The app connects seamlessly with YOLO module for object detection, and family members engage with the system to monitor the user's location. Next slide.
This ER diagram shows that the user has several keys, which include the user's information, and showed that it can be managed by one guardian or caretaker to numerous amount of users which are registered on the app. The user can then also log into the account, which has its own ID and password, and can set one to many preferences as needed by the account user. Next slide, please. The sequence diagram shows that a user and a caretaker or guardian can each log in by adding a user or adding a route to the front end, which can check if the user is authenticated. And a WebRTC connection is established from the front end to the Fast API. The user can also configure settings through the UI of the front end, which will also return the route as entered by the user or the caretaker or guardian. From the AWS server, the route metadata can be saved into the temp storage. And the AI model can also store the route metadata into the temp storage as well. The temp storage can also store important or critical route data as needed, as not to overload the server into the database. And from the front end to the Google Maps API, the geographical location can be requested and returned back to the front end for the user or caretaker to view. And the YOLO route can also be returned back from the AI model to the user as well. Next slide, please. The state diagram shows that the two states are idle when the app is not running or the user has not been logged in. And when the route has been configured, then the application is currently running and active. And when the application is not active, then it is automatically switched to an idle state. Next slide, please. And this class diagram shows that the user has entities of user ID, name, address, and zip code, and actions that the user can take or to configure a route or change preferences. And by analyzing the camera video feed via the AI model, which also includes the model name for YOLO V8, analyzing the video feed. And this creates a route, which includes a route name and can return the route to the user. And the route can be stored separately into the database. And the user can also set preferences such as the font, contrast, color scheme, and privacy settings for the caretaker or guardian to access. Next slide, please.
Hi, this is the Spring One recap. We complete the implement the YOLO module, the authentication, and design the application diagram. Also establish the server for database and server. And number 5 is implement the Google Map API for road detection.
This is a screenshot of the backlog from Jira, which includes several tickets which were assigned to our team members. Some of which includes the architecture diagram review, troubleshooting and recovery functionality, and database overloading concerns. Next slide, please. This shows a screenshot of the Sprint 1 backlog completed after the sprint planning, which includes establishing the clerk for the UI, assigning diagrams, and implementing GPS integration. Next slide, please. This is the completed burn down chart for Sprint 1, which shows the progress for the 45 story points which were assigned for the sprint. Next slide, please. And this shows that out of a total 45 committed story points, 45 story points were completed. So the committed ratio is 100%.
Yeah, this was the retrospective of Sprint Zero, which we presented in the last presentation as well. So if we can move it to the next slide. Yeah, this was the retrospective for Sprint 1. So what went well? Yeah, we were able to complete the MVP, and that during the task allocation, everyone was active and everyone took the tasks in whichever family they were familiar with and in whichever area they wanted to work in. And we also increased our stand-up frequency, and the collaboration was well as well. And the final one was we were able to complete, every task that we scheduled for this sprint. And what needs to be improved, in Jira updates needs to be regular because everyone was not aware of whether in what work has already been done by some others. So if we improve that, everyone will be able to track on like what others are doing. And lack of advanced communication regarding meeting attendance in a few meetings, some people were not able to let us know in advance that they won't be able to attend because of prior conflicts. And then the other thing was scheduling conflict, and then was like sprint planning needs to be at the beginning of the sprint. We delayed it. So because of that, we had to start a bit late. And then the final thing is ensure PRs are reviewed. So by doing this, everyone will be aware of the code that others are writing, and they will be able to suggest improvements if something needs to be improved. And the action items we are taking on all what needs to be improved is we are, sprint planning meeting needs to be scheduled at the beginning of the sprint on the first day, most probably. And then we need to inform the groups earlier in case, you are missing the meeting, so we can reschedule it. And then the next one is making sure whenever you do something, you post it on the Jira ticket and make sure that ticket is in the correct status as well. The other action item is everyone needs to be aware of the schedule and communicate the same to the team on Tuesday before and after the class. And making sure you are reviewing the code when you get notified through the email, because whenever someone creates a PR, all the team members gets notified by the email. So it would be easier just to review that.
This is a screenshot of the Sprint 2 backlog completed after Sprint 2 planning, which includes several tickets such as connecting the Fast API to the Node.js, designing for the login UI, which will be shown later, and the architecture diagram review, which will be added upon later as well. Next slide, please.
Here's the screenshot of the authentication for the project demo. We're having a login and sign up screenshot, and we will having a live demo at, later of the presentation.
Yeah, this is a screenshot for the YOLO detection. As you can see, two streams. The left-hand side screen is what is being recorded by a local camera, and the right-hand side shows what is being returned by the server, which we can show that it is detecting there's a person on the screen. Yeah. Next slide, please. Yeah.
And this is the map detection API of Google route detection. So it shows the route from point A to point B as user requested.
Okay, this one is the wiki page link. If you're interested on our code and how do we do the project, you can click this link to view the more detail on the website. Next slide. Okay, right now we were having the live demo. Uh, okay, here's the this page is the login side of our web application. We're having two functions here. Here's a login function. If you don't have the account yet, you can click sign in to create your account. Let me demo to how to create an account. If you click sign in, you will get into the page of create your account. And you're having two ways to create your account, which is one is connect with the Google, and which is linked to your Gmail account. Another way is by using username, email address, and password to create an account. For this demo, I will demoing the how to create an account with the Google account. Continue with Google here. You can just choosing one of your Gmail account and then agree on those policy. And then after it connect to the Google account, and then click your username here. Okay, here's the sign-in page of the of our web app. Later on, we will connect this page to the real real front end of the web application. If you want to log out, you can log out from here. And next time, if you already have in your account, you can just click login with Google to log in your account from here. Also, from the backend side, we also could be monitoring the what action does the user do. We're having two different accounts, and then what action that's the user taking during while they using the application. Okay, that's the end of the login authentication demo.
So this is the part where we're demoing the YOLO detection part. So we have two streams. On the left-hand side, we have a local stream. So what is being captured by the camera and is being sent to the server. And this connection is made by WebRTC. And we can see that the model is correctly detecting that there's the person on the screen. And we can also see the confidence score. The model is saying there's a 94% chance that this is a person. If I show this my phone, as model can easily say that this is a cell phone. And yeah, so yes, as we can see, model is detecting the objects correctly. So this is just for the demo, like how the model is working. In our actual product, we won't be showing, at least we will not be showing the local stream. we might just show this part, or we might not even show this part. We will capture whatever objects have been detected, and we will use a text to speech later. So that the visually impaired users of this can get the sound, can use the sound of what objects are being detected, and they can be aware of whatever they are seeing in front of them. Yeah, that is it for this.
Map API. So this is the Google Map API that we are using from route detection from one route, like from one point to another. So I'll just type my address, and this is the part we are currently working on for auto suggestions that has been not integrated. Okay, so for this, just put the address I currently am living in. Okay, and to the nearest path station. Okay, so when the users click get direction, they get a direction from one part to another. So later on, we will like implement on the front end to start the route. So user when the user starts, it would be like Google Maps. The route will start with them because we are using the same API. That's it. Okay.
Yeah, in future sprints, we will connecting all these different components together, and in our final products, we'll be demoing it together, not as separate components.
Uh, What? What? Um, yeah, so this was the conclusion from our side for the sprint one. Now we will like working on towards the sprint two. The first thing would be like we will do understand the sprint planning early, and second thing which we will be concentrating would be from tech side would be integrating the Google Maps and YOLO and everything in one MVP project and try to demo it in our end of this sprint to for this for our team. Thank you.